Alright, these are 3D notes. Today we're going to be solving absolute value equations and inequalities. First of all, let's look at some graphs of an absolute value equations. Now recall that the x-intercept is the same thing as the solution for your function or your equation. So notice here that we have two x-intercepts. Our equation touches our graph twice. So that means that this graph is going to have two solutions. Two different x values that will make our equation true. In our second example, our graph only touches once. So this would be an example of one solution. And then our final graph doesn't touch our x-axis at all. So that would be an example of no solutions, or the empty set. And the SOL uses this notation to represent an empty set. So let's go back and do the algebra behind it. So we've graphed and we can see what it looks like graphically, but let's do the algebra behind it. So let's start with, first of all, what is the definition of absolute value? Absolute value is defined as the positive distance to the origin. Mathematically, that means that the absolute value of x equals x for all positive values greater than or equal to 0, x greater than or equal to 0, and the absolute value of x is equal to the opposite of x for all values less than 0, all x is less than 0. There's a distance, that's why we always want to keep it positive. So the absolute value of 5, well, 5 is 5 units from 0, so that's why it's 5. Negative 6, all right, is 6 units from 0, so that's why it's positive. Okay, it's a distance. So when we go through these, the tricks of the trade, when we're solving absolute value equations, we're going to follow these following steps. So step number 1, you must isolate the absolute value equation, or the absolute value symbol. You must isolate it first. Then we're going to break our absolute value into two equations because we're looking for the possibility of having two solutions. That's why we've got to make two equations. Then we're going to solve each equation, and then we're going to check to see if we have any extraneous solutions. Alright, hopefully from your geometry or your Algebra 1 days, you remember extraneous solution is an apparent solution that must be rejected because it does not satisfy the original equation. You always got to go back to the original equation when you check for extraneous solution. So in other words, it's a solution that doesn't work. So that means we always have to check. So absolute values can give us extraneous solutions, and that's something you have to add to your memory banks. Alright, so these are the steps we're going to follow. So let's look at an example. Let's look at the graph. We're going to do the algebra behind that first graphed equation that we saw. Alright, so the first thing you want to do is isolate that absolute value symbol. Okay, now don't fall, you can never distribute, because I can't distribute. This is a big math no-no, that can never happen. Alright, so don't be tempted to do that. Absolute values in parentheses are two different beasts. Alright, so let's use the addition property, and we're going to add 3 to both sides. Good chance to practice our properties. Then we're going to use the multiplication property, and we're going to multiply by the reciprocal. And so we're going to get the absolute value of x minus 1 is equal to 2. Alright, so now that's just step 1. We've isolated. Now, so our absolute value, alright, because the value in here can be positive or negative. So that's why we break it into two equations. We're going to make x minus 1 equal positive 2, or x minus 1 equal negative 2. So we're going to find out both solutions here. We know we have two solutions because we saw that our graph touches the x-axis twice. Alright, let's use the addition property. So we're going to get x equals 3. And the addition property again, and we're going to get x equals negative 1. So from our graph and from our equation, we see that our x solutions are negative 1 or 3. Those are our two solutions. Now, like I said, the biggest mistake that students want to make is they want to break that equation apart before they isolate that absolute value. You're going to get the wrong answer if you do that. So you can only break it into two equations once you've isolated that absolute value. Here again, if you have questions, make sure you jot them down so you can ask them in class. Alright, let's look at another example. Alright, here again, and that 2 is like for example 2. Alright, we need to isolate that absolute value. So that means we need a division property and we need to divide by negative 2. So the absolute value of x plus 2 is equal to 0. All right, break it into two equations. So you've got x plus 2 equals 0, or x plus 2 equals negative 0, which doesn't make any sense, right? So here again, we're ending up with one equation. So here my answer is x is equal to negative 2. And we saw from the graph that this particular graph only touched the x-axis in one spot. That's because it was set equal to 0. All right, so my only solution here is negative 2. All right, let's look at what that thing looked like. So in the next one we have, remember, was no solution. Why? What's going on with this? All right, what do you have to do first? Hopefully you said isolate. So we're going to subtract 2. Equals negative 2. Then we're going to multiply by 2. And here we get the absolute value of x plus 1 is equal to negative 4. Well, recall from our definition that an absolute value always has to be positive. Okay, so an absolute value cannot equal to a negative value. So absolute value cannot equal to a negative. So that's why this one has no solution. Now be careful, because it'll let you do the math. So here's where you're checking. Hopefully we'll catch that. If you don't recognize it at this step, if you continued this problem and set it equal to negative 4 and 4, when you went back to check it, all right, it wouldn't work. So that's why we always, anytime in an equation, plug it back in to make sure it worked. Make sure you didn't do some kind of silly arithmetic. All right, so let's look at another example. All right, here we have the absolute value of 2x minus 4 equals 4x minus 1. All right, notice we have x's on both sides of this one. This is probably one of the more complicated problems you're going to have. All right, so here again, my absolute value is already isolated. Okay, so now I'm going to break it into two equations. So I'm going to end up with 2x minus 4 equals 4x plus minus 1. And my other equation is going to be 2x minus 4 is equal to the opposite of that entire quantity. Make sure you put parentheses around that, because that's another common mistake. If you put that negative just in the front of 4x minus 1, it's not going to get, you're not going to remember to distribute that negative. So make sure you put those parentheses around that equation. All right, let's solve this. So I'm going to subtract 4x, and I'm going to get negative 2x. I'm going to add 4, and I'm going to get 3. So my first solution looks like it's negative 3 halves. All right, let's look at this one. I'm going to distribute that negative first. All right, combine like terms. So I'm going to add 4x, so I get 6x. And then I'm going to add 4, and I get 5. So x is equal to 5, 6. All right, let's check to make sure that both of these worked. All right, plug it back in and make sure both of them work. Make sure you go back to the original equation. All right, because we've changed this. Always go back to the original when you check for extraneous. So let's put in 2 times negative 3 halves minus 4. And we want to know, is that equal to 4 times negative 3 halves minus 1? All right, let's do this. Do the math. Absolute value. Don't drop that absolute value. So this is negative 3 minus 4 is equal to, that parenthesis there. Let's fix this again. I wrote this bad. So it's 4 times negative 3 halves minus 1. Okay. So let's do that math. So that's what? 2 negative 6 minus 1. All right, this is the absolute value of negative 7 equals negative 7. But the absolute value of negative 7 is 7, which does not equal negative 7. So that means that one's extraneous. All right, it worked in our modified equation, but it didn't work in our original equation. So that's the definition of an extraneous solution. All right, let's try the other one, because sometimes we might get two extraneous solutions. So don't, like, just because you find one doesn't mean your job is done. Here again, go back to the original. Plug in 5, 8, or 5, 6. Do this right this time. There we go. All right, let's do our math here. Let's see, 2 goes into 6. That's going to be 5 thirds minus 4 is equal to, that's going to be 10 thirds minus 1. All right, what's that? Negative 12. That's going to be absolute value of negative 7 thirds is equal to 7 thirds. Absolute value of negative 7 thirds is positive 7 thirds equals 7 thirds. So this one works. So that solution 5, 6 is the only one of the two that works. Okay, kind of a hint, if you see x's on both sides of an absolute value equation, make sure you check for extraneous solutions. If an absolute value is set equal to a negative value, that's another time you're going to get something that might not work. Okay, so look out for things like that. All right, so those are equations. All right, let's talk about inequalities now. Absolute value inequalities. All right, so this process doesn't change much for inequalities. The key here to remember is that less than is and. Less than rhymes with and. Less than turns into an and equation. Greater is an or. So less thans are and, greaters are or. I know I'm saying it funny other reason because it's greater or. All right. So in an absolute value equation, when it's less than, you can rewrite it as the compound inequality, as this compound inequality. All right, so let's look at a couple examples, and I'll explain why we have that ors on a boat. Ors point out. So when you're going to rewrite your inequality for or, we're going to write it, so if we had the absolute value of ax plus b is greater than c, our two equations are going to be ax plus b is greater than c, or ax plus b is less than negative c. Ors on a boat, they're pointing outward. So one's going to the right, one's going to the left. Ands point in. Ors point out. Okay, let's look at our first example. All right, now, caution here. All right, caution is the fact that to remember to use that little rhyme, less thans are and, greaters are or. All right, the absolute value has to be on the left-hand side. So must be on left. So our little gimmick, like I said, we have to make things perfect for our little gimmick to work. So before I do anything else, before I decide, like I said, we're going to break this thing apart. I'm going to turn the whole equation over. So I'm going to make this 2 absolute value of x plus 4, all right, is less than or equal to 12. All I did was turn the whole thing over. It's like reading from the back side of the paper. All right, so step number 1 is still going to be to isolate. So don't do anything, change it into two inequalities until you isolate that absolute value. So that means we're going to use the division property and we're going to divide by 2. So the absolute value of x plus 4 is less than or equal to 6. Now we're going to break it apart. Break it up. Okay? It's a less than, so it's an and. All right, now I'm saving you some time here. Remember that little, we talked about over here, this little note. All right? Instead of breaking into two inequalities, I'm going to save some time. I'm going to remember that an and gets sandwiched in between. Sandwich has the word and in it, between our negative value and our positive value. It's going to save me some trouble later on. So when I break this apart, when you break it up, you're getting rid of that absolute value so you can solve it. So since it's an and, less thans are and, we're going to sandwich that x plus 4 in between negative 6 and positive 6. Okay? Now, because these are equivalent statements, I'm just rewriting my absolute value. It's another way of writing the absolute value. I have to do this so I can solve it. So I can't get anything out of that absolute value until I get rid of the absolute value. And that's what this step number 3 is allowing me to do. Okay, now we just solve it. Now it's a compound inequality. Solve it. All right? So that means we're going to subtract 4. All right? Really bad math form here, but I want you to see what I'm doing. I'm subtracting 4 on all 3 pieces. All right? Hopefully you can do that in your head. You don't need to write that underneath. Like I said, bad math form. So I'm going to get negative 10 less than or equal to x, which is less than or equal to positive 2. And that's what I'm going to graph. So step number 4 is to graph it. Alright, so pick a point to represent negative 10. It's going to be a closed circle. And so it's x is sandwiched in between. So now I need positive 2. Draw it to scale. So 2 is over here. Here again it's closed. And my graph is going to be everything in between. So maybe you see now why I got you to review some of the concepts from Algebra 1. So we can hit the ground running. Alright, so summary for this question. The first thing I have to do in order to use my rhyme, my absolute value must be on the left-hand side of my inequality. That's why I flipped this thing over. I have to isolate my absolute value. Alright, since it was a less than, I had to change it to an and. So I rewrote that absolute value as a compound inequality. And then I just solved the compound inequality and graphed it. Alright, let's look at another one. Alright, do I need to change it up? Well, I hope you said no. The absolute value is already on the left. So now I need to go to step 1, isolate. So I'm going to add 2. So the absolute value of 1 minus 2x is less than or equal to 9. Alright, it's a less than. Less than, hopefully you're saying less than is and. Ands are sandwiched in between. Okay, so I'm going to sandwich my 1 minus 2x in between the negative value and the positive value. Alright, sandwich in between the negative value and the positive value. Alright, I've got to isolate that x. So I'm going to subtract 1. Here again, I'm going to do my bad math form. I'm just going to subtract 1 everywhere. Alright, so we're going to end up with negative 10 less than or equal to negative 2x, which is less than or equal to 8. Alright, still got to get that x by itself. So now what do we need to do? We need to get rid of that negative 2. So here again, we're going to divide by all 3 places by negative 2. We're dividing by a negative in inequality, so hopefully some warning bells are going off. Anytime you divide by a negative in inequality, remember those inequalities have to flip over. So this becomes 5 greater than or equal to x, which is greater than or equal to negative 4. Now math, math's kind of picky. It wants things written a certain way. You never write a compound inequality with greater signs. It's always less than signs. So in correct form, we're always going to start with a smaller value, so negative 4, and then our 5. So here's our final answer. You'll never see it left in this form here, bad math form. And we're going to read that as x is greater than or equal to negative 4 and less than positive 5. That's why that and comes in there. Alright, so pick a spot for negative 4. What are we? We're closed. So we're going to close it at negative 4. 3, 2, 1, 0, 1, 2, 3, 4, 5. We're still closed at 5. And we're everything in between. Ands point in, ors point out. All this stuff you have to remember. Okay, let's do one more. Alright, when you look at this, you see that absolute value is on the left. That's good. Check. Alright, we need some isolating here. Let's isolate before we decide whether it's the greater, a less than, or an and. Less than or greater. Alright, so you got 1/2. I'm going to subtract 2. So I get 6. And then I'll multiply by 2. So the absolute value of x minus 11 is greater than 12. Alright, now we get a sign. This is an and or an or question. Or greater is or, so this is going to be an or. Ors point out on a boat. So we're here again, we're rewriting this. We're just rewriting a different form, so we're getting rid of that absolute value so we can solve this inequality. So x minus 11 is greater than 12. Or x minus 11, flip the inequality, change the sign on that second equation, or second inequality. Flip the inequality, change the sign. Alright, now we just got to solve both. And make sure you have the word or in there. You must have the word or for your answer to be correct. Alright, so we're going to add 11. So x is less than 1, negative 1. Or add 11. So that's 22. positive 22. All right, let's see. Let's count our graph by 2 so we can fit both of these on there. All right, so negative 1. So let's make this negative 2 down here. So this will be 0 because we're counting by 2's. All right, so negative 1, and we're open. Put an open circle at negative 1. Let's count by 2's. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22. So we're open at 22. And we want ORs. So it's less than negative 1 or greater than 22. So here again, ORs in the boat's pointing out. ORs point out, ands point in. All right, if you have any questions, please ask. Like I said, we'll talk about it in class and you'll have some time to practice.